Hello, everyone. Thank you for joining us for La Kopi today and spending your Thursday evening together with us. So we have a couple of minutes before our session starts. So we want to get to know our speakers better. So today we have Dewey, Shubhanshu, and Silvia joining us. So we have a question for them. So they'll be sharing what's their ideal work environment. So, for example, do they work best with music or no music? Do you prefer standing or sitting down? And you can even share whether you miss going to the office or you're totally happy working from home. Let's start off with Dewey. What about you?
Actually, the ideal work environment for me, for the music things, actually, it depends. When I am in a focus mode, I prefer to listen to any music, any instrumental music, because I can easily get distracted with the lyrics come to my mind.
Mm,
But if I have to do a less focused task, I like to listen any pop music randomly we can find in my playlist. And then I
nice.
prefer kind of that. And then I prefer standing rather than sitting.
Mm.
Yeah,
Also,
because it's like I have to do exercise by stand in a long time rather than by sitting. It's more like a lazy mood for me.
okay. I'm the opposite from you. I love to sit down. So
Oh,
yeah, there were a few people who were getting standing desk, but I was wondering would I really use it? So I decided not to get it in the end. Yeah. What about you, Shubhanshu?
Yeah, so completely resonate with Dewi's thought on the music choice. So I generally listen to Indian classical instrumental music when I want to go into deep, thoughtful zone,
Okay.
deep work. And obviously loud music that sometimes people sitting nearby complain that, yeah, what are you listening to? But yeah, so that's the music choice that I have, and
Mm-hmm.
I do have a sit and stand desk. So my usual choice of taking meetings is while I'm standing.
Mm.
Um, that is actually what I'm doing right now as well.
Okay.
So yeah, that is that, and uh, yeah, I'm enjoying the work from home mode, but I do sometimes miss going to the office. I joined my company last year during the lockdown, so I
Mm.
miss the networking that uh, I could have done if the
Mm.
office would have been on, but still. Hands down, the work from home is still a preferred way to work
Mm.
going forward as well. Yeah,
Yeah. Yeah, totally agree with you. I
yeah,
also joined the team last year when the pandemic was going on. So,
yeah,
yeah, so super relatable. Yeah.
yeah.
What about you, Sylvia?
Yeah, it's funny because I also got a standing desk
Oh,
so that I will get motivated to use it. But look at me, I'm sitting right now. That ends up being most of my time actually. But
okay.
I try. Sometimes I'm like, oh yeah, you know what I could be doing? Standing. Maybe. So I try. I love working from home, but
Mm,
I do miss going to the office, especially because I don't know, talking to colleagues.
mm,
It's so much more fun, and then I working in the CBD area is fantastic because there's so much good food around. So it's very good. I always want to try new different places, so that keeps me
mm,
motivated. But at the same time, like the commute, I don't know, spending 2 hours per day in commute is not. It might
yeah.
not be worth. So I'd rather get Deliveroo or going out for dinner. So I try to keep a little bit of balance between going to the office and staying home.
Nice. So, how many percent of the time are you sitting down or standing up?
I don't want to admit that to myself. That's gonna be a secret. The moment I say
Okay.
what it is, then I'm like, why did I spend $700 on this standing sitting desk?
No, you make me feel like I did the right choice. Not getting a standing desk. Yeah.
How about you
Thank.
guys in the audience?
Yeah, let us know in the comments. I'm really curious whether a lot of folks got the standing desk because I feel like I've been hearing so many people getting them. Yeah, but if you have a standing desk, let us know if it's worth it. Yeah, really curious to know. Yeah, thanks so much for sharing your thoughts with us. So we are gonna start the session soon. So I'm just gonna do a quick introduction to DevSpace and Lakopi. So I'll move the speakers backstage first, but see you all in a short while.
Sure.
Bye. Hi everyone, a big hello to all of you and thanks again for joining us on a Thursday evening. I'm Jia Sing from the Google Developer Relations team and we look after the developer and startup community in Southeast Asia region. So for today's Lakopi is going to be about data science. So we are really excited for the awesome session we have lined up for all of you. And so these are the three speakers that are joining us today. We hope you got to catch a couple of minutes prior to this where they were sharing about their work environment, whether they are using standing desk or not. Yeah, so they will each be sharing for about 10 minutes and you're welcome to submit your questions to us via Facebook or YouTube live chat, wherever you are viewing this from. And we will answer your questions after each speaker. So for today's session, we have Shubhanshu Gupta, who will be sharing about reimagining topic modeling in NLP, a break from conventional approach. And next up, we'll have Silvia Lara showing us how to forecast your product's demand with machine learning. And last but not least, we have Dewey Octaviani, who will be sharing about building a data pipeline for conversation logs. So without further ado, I'm going to welcome our first speaker for today, Shubhanshu. And yep, so let me just get the panel up and running. So Shubhanshu is working as a machine learning engineer at Citibank. And he is going to be sharing about reimagining topic modeling in NLP. So when it comes to topic modeling, most of the NLP practitioners use LDA, latent dirichlet allocation. Pardon if I'm butchering the term, or LSA. He is here to challenge the convention and think outside the box. So in this talk, he will walk you through an example using named entity recognition and collocations, which used high quality and meaningful topics and visualizations. So a lot of terms, but I'm sure he will break it down to you and show you how you can use it. So really looking forward to hearing about your project, Shubhanshu. The stage is yours.
Hi, everyone. I'll start the talk with a general theory. So in general, to tackle problems in our professional space, I'm sure we are all used to adopting the approach that is in use since a long time. It's an industry standard or is a known formula. Even in data science, there are ample of set or predefined models or algorithms for so many use cases that it's not surprising if somebody has already done what you want to implement. But still, the results sometimes don't make sense to you, or you're just not happy about the quality of the insights. Well, this happens a lot of times when you're building data driven solutions. Sort of similar thing happened with me too. The problem statement, the huge text corpus I had with me required me to extract themes or topics out of it. What eventually happened is what this talk is going to be all about. I thought and took a completely uncharted path for a problem statement such as topic modeling, which by the way is pretty standard and has established models all across the internet. The result that came out not only impressed me, although I'm probably building a lot of hype right on the first slide, but yeah, it also impressed the stakeholders because they got whole new level of dimensions into the insights, which the regular topic modeling fails to deliver. So let's dig in. A little bit about me. I work in City, Singapore as a machine learning engineer. I previously held data science roles in ad tech domains. I did my master's in data science with specialization in consumer analytics from National University of Singapore. I spent about 3 years prior to my master's working for early to mid-age startups and wore multiple hats of product development and analytics. As a part of giving back to the community, I mentor and guide folks who are aspiring and applying for master's studies. I mentor them with their essays, interview prep, and overall application. One fun fact about me, I'm a part of an imaginary tea cult. I don't have blood, only tea. Let me know if you want to join my tea cult. Okay, so this is how the outline of the talk that's going to look like. We will start with the what's topic modeling. We'll discuss the conventional approach. Next, I'll introduce you to the new approach that addresses the flaws of the conventional method. Towards the end, I'll give you a few pointers to further enhance the capabilities of the new approach that we are going to discuss. Topic modeling is one technique in the field of text mining. As the name suggests, it's a process to automatically identify topics present in a text object and to derive hidden patterns exhibited by a text corpus, thus assisting in better decision making. I'm sure many of you would be aware of the relevance of topic modeling, but some of the use cases are like tagging customer support tickets according to the topic, routing specific customer complaints to the relevant teams, and so much more. We'll also talk about one particular use case in the subsequent slides as well. Okay, so first we'll talk very briefly about what's the conventional approach. Although there are many approaches for obtaining topic from a text, but LDA, also popularly known as latent Dirichlet allocation, is one of the most popular topic modeling techniques. A very simple explanation and a layman explanation. Latent, this refers to everything that we don't know a priori and is hidden in the data. Here, the themes or topics that document consists of are unknown. Then Dirichlet, it's a distribution of distributions. Here, in the context of topic modeling, the Dirichlet is the distribution of topics in documents and distribution of words in the topic. Allocation, this means that once we have Dirichlet, we'll allocate topics to the document and words of the document to topics. That's it. That's what LDA is in a nutshell. I won't bore you with a lot of technical terminologies. But obviously, there are some flaws in LDA, and that's why I'm presenting, right? You have to decide the number of topics you want from the text before training the model. That's quite weird, right? How do you know how many topics will be able to justify all the content present in the text? Then LDA can't capture correlations. By correlation, I mean, let's say if I'm searching for a particular topic and I come across a topic that makes me want to read that article. So I would obviously be interested in another highly correlated topic that I may not know about. Next, there's no to very little context in the topics. You have to infer the context all on your own. And yeah, LDA uses bag-of-word approach, which hampers in capturing context between the words. You will know a lot more about these flaws later when I show you a counterexample. Okay, so now we have gone through what's topic modeling, what's LDA, and what are some of its flaws. One of the flaw that we discussed was lack of context in the topics, churned out by LDA. So let's look at contextual topic modeling. First, I'll help you visualize what's a contextual topic. Imagine a scenario where you know the prominent theme that is present in the text that you are analyzing, such as Saturday or kids in, let's say, restaurant reviews. Now visualize what people are writing about or around those themes, such as Saturday brunch. And the actual review could be, I went to have brunch on Saturday with my family. Similarly, great kids menu. And the actual review could be, the restaurant had a great kids menu. That's your topic. Yeah. So the point is the overarching themes, which in this example, Saturday and kids, plus finding the most probable phrase that occurs in the context of the theme. In this case, Saturday brunch or great kids menu. These things together constitutes the contextual topic. Saturday kids that you saw in the last slide were possible because of something called named entity recognition. It locates and classifies an entity into predefined categories such as person, product, organization. Then comes the phrases like Saturday brunch, kids menu available, which are called collocations. These are phrases or expressions that are highly likely to co-occur. Together, these two components constitute the essence of a new way to approach topic modeling. I'm going to quickly run through the data pipeline that I used for my example. I used TripAdvisor reviews. For EDA, I just used the general off-the-shelf um, libraries, but most prominently for the models, I used Spacey for its language model. I use DeepPavlov. It's a deep learning library for performing named entity recognition. Basically, it's a library in which you can do a lot of NLP tasks, but I use that library for NER. Then I used NLTK for collocations. The data set that I used was Sentosa attraction reviews on TripAdvisor. There were about 900,000 words present in about 27,000 reviews. Performed NER on the data, which led to the discovery of the entities within the text. So the table that you see on the right column of the slide, it describes the NER table. The entities extracted from NER are represented in that table, like person, date, day, organization. For example, if I perform NER on the sentence, I ordered cake for my wife on our anniversary at Sentosa. So here, NER will be able to identify cake as a product entity, wife as a person, Sentosa as a location, and anniversary as an event. Cool, isn't it? So the next step was to implement collocations and extracted 2 to 3 words surrounding each entity. That's how we got topics of phrases like kids menu available, uh, celebrate girlfriend birthdays, etc. We'll look at those examples in the upcoming slides. So what you see here is a tree map visualization. One thing to note about this kind of visualization is that the darker the color, you can expect that particular topic in the box to be more prominent in the text. This particular tree map visualization is just made out of the themes present in the day entity and the collocations present around the day word. Okay, now I'll explain you the power of this technique and how contextual topic modeling helped my stakeholders take better decisions. We see that there's a lot more conversation around Mother's Day in the reviews, even more than the Valentine's Day. This allows digital marketers to target and run promotions and campaigns on Mother's Day as well, an insight that might not be known to the marketing team, but now a valuable insight, all because of a contextual topic modeling that could dig what people are writing around the day theme. It's highly likely that for Valentine's Day, only a couple might visit the restaurant, but for a Mother's Day celebration, a whole family might visit, thus leading to more revenue per marketing dollar. So you see the power of the kind of insight that this contextual topic modeling is bringing onto the table. Another example, there's a lot of chatter around weekend mornings, Sunday morning being the most talked about. Ironically, avoid mornings also stood out. Thus, it implies that people who visit the place on weekend mornings and find a lot of rush, they also write about avoid morning hours. This kind of contextual topic modeling also helps you understand when does your audience visit your place and avail your services. It's a great insight to have for your campaigns and tapping the behavior of your customers and audience. Another great insight to know is who are your customers. Birthday celebrations by girlfriend, boyfriend indicate younger demographics. This can help you frame your target audience and plan promotional campaigns accordingly. For the same dataset, the 5 topics are extracted using LDA are as shown. As you'll go through the topics, you will see that it's up to you how you want to make sense of your topics and stitch your story when you use LDA. But that's not the case when with the technique that I demonstrated. So we saw a lot of evident differences between the topics found via LDA and the tree map visualization showing the contextual topics. A few things are pretty clear. The topics, even though with fewer words than the one given by LDA, are much more meaningful and interpretable. The variety of topics is way more in the case of NER and collocations. The example you saw in the previous slide was just of the day theme. We could pull out several themes and find topics around those. You would have observed that I mentioned interpretable topics. Interpretability is the thing that your stakeholders, your business would love to know. But everything is not rosy. There's one problem though. It's not a problem, but more of a tedious task. One has to cherry pick the entities of interest from the NER exercise. So, for example, person entity may have several themes, such as wife, husband, boyfriend, girlfriend. The entity might have all days of the week. So, the point is that you have to keep discussing with your stakeholders. This is more of a solution to tackle this tedious task. The more you discuss with your stakeholders, like what they want to know, who are their customer base, do they want to know whether people come to their place on a weekday afternoon or evening? Once you know these kind of information from the problem statement, it becomes a lot more convenient to comb through the entities. One possible enhancement in this technique is performing sentiment analysis. For example, knowing whether people express negative or positive sentiment around a review like watch divers feeding marine life. It can change the narrative of the marketing campaign. So, from behavioral insights like who are your customers, how many of them visit or avail your services, what are they interested in, what do they buy, what activities do they engage with, it can help you understand your offline and online audiences both. So this wraps up my presentation. I hope you took away something meaningful and something to explore beyond the traditional approaches of traditional topic modeling. You can find actual code samples on my blog, and yeah, you can reach out to me over LinkedIn, Twitter, DM me. Just feel free to shoot questions or connect, or even share with me your thoughts. Would be glad to know um, your takeaways from this presentation. Thank you.
Thanks, Shubhanshu. That was a really interesting presentation. Yeah, I really like the part where you shared how you could apply it to the marketing teams, and how by seeing what people are actually posting about, it actually tells
Yeah,
you which are the target audience that your campaigns can probably
exactly.
focus on. Yeah, it was really interesting. So if you have any questions for Shubhanshu, feel free to leave it in the chat. I think he will still be able to answer them there. Yeah, but if not, feel free to get in touch with him via his LinkedIn or Twitter to take your discussion further. Thanks a lot for joining us and sharing your project, Shubhanshu.
Thank you. Thank you so much.
And for our next speaker today, we have Silvia Lara. So Silvia is a graduate from our Women Developers Academy program, and she's a data scientist at LinkedIn in the economic graph team. Her experience revolves around creating machine learning and statistical models to forecast demands in an accurate and scalable way. Usually, she spends her days translating business problems into analytic solutions or reading about desserts recipes online. The stage is yours, Silvia.
Hi everyone, thank you so much, Justin, for the introduction, and thank you, Shubhanshu, for the very insightful presentation. I learned a lot. So, and thank you all for joining me here today. So, what we're going to be learning is about how to build machine learning model for demand forecasting. So let's get started. As Justin said, I'm Silvia, and I work as a data scientist at LinkedIn. And this is my first week at LinkedIn, actually, so exciting times. So before joining LinkedIn, I was working at Stemly, which is a startup here in Singapore, interacting closely with our customers and translating their business needs into machine learning models. My main focus was building forecasting models for our customers. So using one of our projects that I worked on in the past year, we can learn how to apply machine learning to forecasting. Let's go for it. So there are a lot of similarities between building a model for the time series forecasting and any other task, whether that's a classification or a regression task. So the steps are data processing. Then we might want to do some feature engineering, hyperparameter tuning. We then validate our predictions and we analyze the predictions at the end. So the main difference between forecasting and any other task is on the feature engineering, validation, and analysis stages, which is what we're going to cover in the next 10 minutes. So the project that we will be focusing on today is a demand forecasting problem. So it's in the supply chain domain. So for those of you in the audience like me 2 years ago who do not really know how our favorite products end up in the shelf or on our Shopee cart, let's take a look at a simple diagram of the supply chain. So here we can see the flow of goods from raw material to consumer, first passing through the supplier's hands, then in the factory of the manufacturer, and then the finished goods are distributed by the distributors to the retailers, and then they end up in the consumer's hands. So in this project specifically, we want to focus on the manufacturer to distributor link, and we will refer to this flow as shipment quantity. So the task at hand, more specifically, is to help the manufacturer know how many units of each product the distributor will buy every day for the next 12 weeks. So put yourself on the shoes of the manufacturer who wants to know how many shampoos the distributor is going to be ordering every day for the next 10 weeks. So what does shipment exactly mean? So here with shipment, as we mentioned, we mean how many units the distributor will ask me, the manufacturer, to send them. So that's our target variable. So now that we know the target variables and we have historical data for this, are we just good to go? It's a little bit difficult, and before we dive into which model will do best and show off our knowledge of the most complex deep learning networks, so let's see what factors actually what factors influence our target variable. So forecasting is a little bit of an art, and it's currently done in most companies through simple technology, like Excel, but relying on years and years of personal experience by the demand planners. So the key of an effective model is actually understanding which factors will end up affecting your demand. So what would you personally consider first if you wanted to know how many bottles of shampoo the distributor in Malaysia is going to ask me tomorrow? So an example would be, let's see if, yes, I got it to show up. Yeah. So one possible factor would be how many units are the distributor themselves going to sell to the retailer when in a flow of quantity that we call sellout. Of course, the number of shampoos that I currently have on hand is going to play a role. I might not have to produce as many if I have already a lot. And what about the distributor's current inventory? If they overstocked last month, they're not going to be ordering as many next month. And of course, all of these factors are affected by price, promotion, and market conditions at every step of the way. So the question is, how do we encode these features? And once we encode them, are we done? I mean, not really. So let's take a step back and think about how we can encode this time series data for a tree-based model, for example. So each row is characterized by a date and ID. For each ID and date combination, there's a target variable. In our case, we call this volume, which is our shipment. So you can join whatever information you'd like on the ID and date. You can join the product information, the price information, location, temperature of that day, if you join it on date, for example. But how do we encode the sequential nature of the time series, which is the key difference between time series data and image or text? So the way that we do it is that we add lags. So what was the quantity yesterday? We call that lag 1. How about 2 days ago? That's lag 2. So similarly, you can calculate a lot of features based on the time series itself. So the key to understand how people do currently forecast is understanding what affects the demand, we said. So let's first make a hypothesis. Then we'll run an analysis to verify the hypothesis on which feature will make the most sense. Analysis is super important. Is your data seasonal? Is it intermittent or is it smooth? It is really important not to get married to your hypothesis. Your model is the one that will tell you whether a feature is relevant or maybe not as much. So make sure you do feature selection. So let's go through some of the examples of the features. So some example of features that we talked about are the external data features, like sellout, inventory price, all of the ones that we talked about. But there are also intrinsic features that we mentioned earlier, which are the lags, or the moving average of the volume, for example, and then other statistical features like kurtosis and skewedness that might remind you of your stat courses back in university, or like differences and derivatives, which are actually time series. So instead of encoding just one number, like a lag 1, I might want to say, okay, what was the difference between yesterday and today? And that would be the difference 1. And then the difference 2 would be the difference between 2 days ago and and yesterday. So you can have a ton of different features. So for each feature, it's really important that you consider a few questions. So for each date and ID combination, which quantity of the feature do you want to consider? That's the time frame. Do you want to consider the same dates? Do you want to consider the cumulative value for that week? Or maybe you want to consider 28 days before that value, because you need 28 days for the lead time. So for features like lags and some other difference in feature, which are time series themselves, you might want to consider how many units of time do you actually want to consider. Do you want to consider all of the time series for the last 30 days? Or maybe for the last year? Or maybe do you want daily data or do you want weekly data? So all of these are decisions that you want to make based on the business context that you have, based on your understanding of how this product actually behaves. Then once you have these features, you have your feature dictionary, let's understand the relevance, determine the feature importance. Is the feature importance what you expected? Is it what your business owner expected, the person who knows the most about how these products behave from the business standpoint? And if not, does this make sense? Does your insights make sense once you take a look at the data? If they don't, then there's something wrong with your code, so let's go back to feature engineering. Something that is incredibly important that you should consider is, will you have this data at prediction time? So for example, let's say that you want to forecast the sales of umbrellas. And you know what? What's a better predictor than the weather for the sales of umbrella? It makes sense, right? So you want to do a forecast for the next month, daily sales. But then when you do the forecast, you need to know what the weather will be then. And that you don't really know. So should you use the weather data in your forecasting exercise? Maybe you want to use a weather forecast, but there's a lot of uncertainty in that. So what are the implications? Consider it carefully. So now you have all of your features, but do you know how your model works? We need to compare our forecast with the actuals. So some of the error metrics that we use in time series forecasting are similar to what you've seen for other tasks. Shubhanshu might use these ones too. So we have MAE, which is the mean absolute error, and RMSE, the root mean squared error. In both of these, you're taking a difference between the actuals, A, and forecast, F. And in one case, you're taking the absolute difference, and the other case, you're squaring it and then taking a square root and doing some averages, just so we can have one number. So now imagine this. You have to go to your business owner and tell them, look, our forecast has an error of 3 or 10. Okay, thanks. What does that mean in terms of the impact of my business? Is 10 good? Is 3 good? What? So that's why everyone loves MAPE. So MAPE is the mean absolute percentage error. And like the name says, what we do is that we take our difference between between actuals and forecast, and then we divide it by the actuals. So the business owners love it, but the data scientists hate this metric. And can you tell why? So what happens if 80 is 0? Yeah, bad things happen when you're dividing things by 0. So another issue is that under-forecasting and over-forecasting are not equally penalized. Think about it, left as an exercise for the reader, for the watcher. So that's why there are a lot of metrics that try to walk around these shortcomings that we highlighted just now. So I'm putting a few actual metrics that end up being used more often. So some of them scale the error instead of scaling by the actual, they scale it by a naive understanding of it, or some of them weight up the error by some more business-friendly quantities like the price or the revenue. So those are the weighted metrics that you see with the W there. So you could stop now, but you probably have the different models are better for different products or dates. Maybe you have that an LGBM model trained only on shampoo does really well for the shampoos, or for Singapore products, the Singapore trained model is better. Or maybe you know that for shampoo specifically in Singapore, the best model is the one that has only seen shampoos in Singapore. Or maybe an ARIMA model would be, which is a statistical model like SES, will do much better with a different, for some types of products. So if only we could choose the best model for each of the IDs. But we kind of can. So how about we build a model that chooses which model to choose? That's very meta. We call these ensembles. So the idea is to train very different models and put their errors as training data for a stronger learner that then decides based on the error which model to choose in the right circumstances. So this is when diversity becomes extra important. The more diversity, the better the accuracy. Because sometimes a simple exponential smoothing is all what you need, is all that you need. So with this technique, we delivered 10% improvement in the client's already best-in-class forecast accuracy. So this recipe ended up working for us. Let's see. I hope you learned something about defining forecasting model for demand forecasting and which guiding questions are important when interacting with your customers. So it's time to test it out and let me know what percentage accuracy you get. Time series forecasting is really everywhere. I mean, stock prices are time series. Hint, hint. It's not an easy problem, but there's a lot to learn along the way. So what are the steps? Let's recap a little bit. So first thing, understand the business requirements and the structure. What are you trying to solve exactly? Then choose your features very carefully. Validate your results for future accuracy. And then make sure that you diversify your models. You consider different opinions. Diversity is always a good thing. And then optimize again, not just for the most relevant metric for your business. So keep that in mind, and I'm sure you'll give me a success story. So write to me what your percentage accuracy would be, and if you have any questions, drop them in the comments section. And if you want to learn more about time series forecasting, check out what Stemly does in their blog at stemly.ai/blog, and or in my LinkedIn profile. Connect with me on LinkedIn and make sure you add a note to remind me where we met. So good luck with forecasting.
Thanks, Silvia. I feel like I was back in math class when you were showing all the formulas. Yeah, we do have a comment from SC Ang. Maybe this person missed a part of the presentation. So SC is asking, I think for the formulas that you shared earlier, which metric do you use for which purpose?
Yeah, that's the really important question. And I decide which one to use based on who I'm talking to and what exactly I'm doing. So if I'm fine-tuning the forecasting model for my own purpose, so let's say that I have 3 different models, then I want to see which one performs better for a certain product, then I might use one of those. Usually I use weighted RMSE or the SNAPE, which is like the symmetric MAPE, like the percentage, but making sure that over forecasting and under forecasting are treated equally. But if I'm presenting to a stakeholder, then, and these metrics might be a little bit too complicated to explain, then I might end up using MAPE, because sometimes that's what the business uses, and that's what they want to hear. Or I try to introduce them to one of the simpler metrics and then link it to their business. So it really depends on what I'm trying to achieve. But the most important thing is that the person that you're talking to has to be able to be on the same page as you. Otherwise, there's no communication.
Yeah. SC, we hope that answers your question. We have another one from Esther. She asks, what about outliers? Is that important and how do you address that?
That's really important. Good, yeah, very good question, Esther. So the first thing that you do is actually when you do the analysis, you should remove the outliers. So do a bit of outlier detection, and there are multiple techniques to do that. Because once you put your data through the machine learning black box, then the outliers might create problems. But you need to be very careful because sometimes those outliers are actually what you want. Like, for example, if you take a look at 1111 sales, those are definitely outliers. But if you were to just remove them, you will lose a lot of the signal. So what you might want to do instead is build a model to detect those outliers and build a model to predict everything else. So you have a very powerful model that is really good at predicting 1111 sales, and then you have a model for your everyday sales.
Nice. Okay, I think another question from Geraldine. So she asked, thanks for sharing. What do you think about packages like TS Fresh for automatically generating time series features?
Oh, that's always my starting point. I import the most amount of packages possible. I create a feature dictionary that is huge, so that then I can select down and really figure out which ones are the ones that work best for this specific use case. But sometimes some of these features are really abstract and not really relevant to the use case of that specific client, which might have always a 6-month lead period. Then you might want to focus specifically on those type of features. And you might want to always add some additional ones, like the external data features from the sellout data or the price that the customer might have. And those actually end up being much more important than the out-of-the-box features, unfortunately.
Yep. Nice. I guess the last one is not really a question, but just a comment from Ray Key. Thanks for sharing, considering to explore more into forecasting. And this is just what she needed to know.
Thank you so much, Ricky. I'm glad it helped. If you want to ask any questions, you know where to contact me now. I'm happy to help.
Thanks a lot for sharing, Silvia, and thanks everyone for your questions. If you have any more, do feel free to leave them in the chat. Silvia will be able to reply you there, or feel free to get in touch with her via LinkedIn. I'm sure she'll be able to discuss more with you there. Thanks a lot, Silvia.
Looking forward. Thank you.
And last but not least, we have our third speaker for today, Dewey Octaviani, who is also one of our graduates from Women Developers Academy. Dewey is currently working as a data engineer in Kata.ai. In this role, she focuses on providing millions of conversation logs of data to stakeholders and also focus on data engineering challenging cases. Outside of work, she's a mom of a daughter and is now learning about parenting. This talk will be explaining about a set of actions that ingest the conversational data from sources, and she will also go through how you can transform the data to a columnar format and move the data to a storage for further analysis. Yep, the stage is yours, Dewey.
Thank you, Jiaxin, for the introductions. Okay. Okay, so hi everyone. I'm so happy to share my experience on how to build a data pipeline for conversation logs and retrieve information for analytical purpose. Well, actually the theme of this presentation might be more data engineering things than the data science thing like what Shubhanshu and Silvia's presentation, but I hope you enjoy this presentation. So before we begin, let me introduce myself. I'm Dewi Octaviani. I got my master's degree from Waseda University on 2017, and currently I'm working as a data engineer for 2 years in Kata.ai. In a day-to-day, I'm responsible to manage Spark job for ETL process for the conversation logs behind the client's chatbot, and then manage active scheduler on Airflow, and then write queries for reporting, and so many data engineering jobs. Feel free to contact me on my GitHub and LinkedIn account. Okay, let me explain a little description about what Kata.ai do. So in general, we provide a conversational AI for better customer experience. We have many products, but our main product is a web platform that enables you to create a bot with almost no code implementations. And then we can predict sentence and train the model with training data that you want the bot to understand on this Kata platform. And the last is we can deploy the bot to multiple channels that are available in Kata platform without worrying the API for each messaging channels. So once the bot is successfully deployed, the bot will respond accordingly to our customer. As the company grow up and the pandemic hit, we handle more and more clients coming from the especially public sectors because since the social restrictions happen in Indonesia, those makes the conversational data grows rapidly. So now we handle more than 750 million rows of conversations and more millions data are coming every single day. Here comes the challenge on how to build a data pipeline to handle the growing conversational logs and how to process the data and give valuable insight for the bot owners, business analysts, or the stakeholders. Let's say we create and deploy a bot in Kata platform. So I think it's normal for us as the bot owners that we want to know how many users are interact with our bot and what kind of interactions that happen between our bot and customers and about the time when it happens and so on. And those are what the data engineers' responsibility to sort out problems and bring the solutions. But first thing first, we have to explore how the conversation logs are processed by our microservices. Okay, this diagram describes how conversations are processed by our microservice. This all started when there are incoming messages from any messaging channels such as WhatsApp, Telegram, Line, and so on coming into our system. And then our webhook service parse and serialize the message into a schema that understandable by our microservices. Webhook service then publish the serialized message to RabbitMQ as the message broker. Here, message broker is important because it will requeue and resend messages whenever the destination service are unreachable. It will also guarantee that message sent between services are delivered orderly. The message broker delivers message to dialog engine service. This service and then forwards the message to an LU service for intent classification and entity extraction. An LU service will chunk down the message, extract the entity, predict intent, and then once the result is there, the result then sent back to the dialog service engine. And then in dialog service engine, when it receives the result, the intent classification and the entities extraction, it will map the predefined reply message based on the intent and send back the reply message to the channels. And then those process makes the bot knows how to respond right based on the incoming message from the customer. And then the next important thing is how the strategies or how the steps to retain conversation logs on our data pipeline and utilize it for analysis. Okay. So we need to find out the steps required to build a system that can retain conversation logs. First, we need the temporary message to retain the streaming data. And then second, we need the framework that can do extraction, load, and transform the streaming data transfer. The streaming data faster. Sorry. And then the third, we need a distributed file system that can support the processing data. And then the fourth, we need an OLAP or online analytical purpose database to support analytical report. And the last, we need automation tools to chain all the process. Yeah, all those chain steps that I explained before is what the definition of data pipeline is. So the data pipeline is a set of tools and processes used to automate the movement and transformation of data between a source system and a target repository. Here, I think it's me and other data engineer who trying to pull and connect the pipe so that the data can pass through from certain sources to the target destinations. These diagrams show how the conversation logs are processed. And in order to retain the conversation logs, we need to create additional service that listen to the incoming messages from RabbitMQ. And then let's go to the first step to store conversation logs. We need to implement a message log to temporarily store the data. Okay, the one previously mentioned before, that those additional service is a parser service that listen to RabbitMQ, which parse the messages and add event time and then publish the message to Kafka. Apache Kafka here is a distributed event platform that capable of handle trillions of streaming message and persist it on disk for a certain time. And then now we have our streaming conversation logs stored in Apache Kafka. Then what is the next step? Okay, let's explain the number 2 until number 5 in one go. Okay, here we use Apache Spark as the in-memory processing, which means all the transformation process is done in memory, not in disk. That's why Spark operation can process streaming data faster. We run a Spark code to read the stream messages from a Kafka topic. And then we select only columns that we need and then add datemap partitions. And then write the transform data stream to Google Cloud Storage in a Parquet format. Anyway, we run multiple big data tools here, such as Apache Kafka, Apache Spark, Apache Airflow, Hive, Trino on Google Kubernetes engine. And we use Google Cloud Storage to store the Parquet files. And then we store the conversation logs in a Parquet format. Parquet format is a data binary files in a columnar storage format. Why is it columnar storage format? Because it supports faster query analytics. Columnar storage stores data in columns rather than the rows that usually used by traditional databases. And then distributed file system is any file system that allows access to files from multiple hosts sharing via a computer network. Here we use a Hive metastore to support metadata storage for the Parquet files. This metastore, this Hive metastore is used by Trino, or previously known as Presto, as the query engine. Then Trino will map the metadata information and the Parquet files in the Google storage to discover the data in a table view. And the last, we use Airflow as a tool to scheduling the Spark job to run at a certain time in a day, so we can track the progress, logs, code, and trigger tasks and success status in the Airflow dashboard. And then once we have applied the data pipeline, we can curate the analytic results, such as here. This is the word cloud chart where display the most used sentences by user. But I think it shows Indonesian sentence like promo, hello. Yeah, I hope you understand. And then the next is this shows the peak hours that displays the most interactions happen between clients and bot. The darker color means the most interaction happen at the time. And then finally, here we come to the conclusions that there is no silver bullet in building a data pipeline. We should follow the company considerations and characteristics of each tools to make use the tools wisely. And then a reliable data pipeline will help business analysts and stakeholders to get insight efficiently. I think this is the last part of this presentation. Thank you for listening, and feel free to connect on my LinkedIn and GitHub. Thank you.
Thanks, Dewey. That was a really interesting presentation. I realized earlier on when you were showing how much interaction there is for the different days, Wednesday seems to be the one that has the most interaction. I'm wondering, is there a reason why?
Wednesday. Oh, yeah. I think at that time there were like a message blast from the company. Maybe it's like a notification for the customer that a promo there are discount or promo happens.
I see. Thanks for answering that. Yeah, we have a question from Jeff. So Jeff asked whether there are any challenges faced when a timestamp value is stored in the particular time rather than conventional day, month, year format. If yes, how is that managed?
Where there are any challenges faced? Oh yeah, actually the timestamp value stored in Parquet format. Why we use timestamp value in the Parquet format? Actually, we use a certain so we have a partition date in a Parquet format, which are used as the partition table to make the query faster. So we have a format like DD, MM, YYY. But for the timestamp, we don't use timestamp as the partition date, but it is only for the information that the conversation event time happen at those timestamp value, something like that. Maybe I hope it answers.
Yep, Jeff, we hope that answers your question. If not,
maybe,
feel free.
Yeah. Maybe I can write the answers on the YouTube comment, or you can contact me.
Yep. Yeah, feel free to connect with Dewey via LinkedIn as well. If anyone has any questions, feel free to just continue leaving them on the chat as well, or you can also connect with our speakers directly. Yeah, I think that's all we have for today. Thanks, Dewey. for sharing your project with us. Really different from Shubhanshu and Silvia's one, but still interesting nonetheless. We hope everyone learned something out of it.
Yeah. Thank you so much.
Yep. And thank you everyone for joining us for Lakopi today. We hope the projects from our speakers were interesting and you learned something, and hopefully you can apply something in your work, or even if it's a project that you are interested to get into, we hope that the tools they shared will inspire you and you can check them out as well. And if you missed any of the session and you would like to rewatch it, don't worry, the session is still up on our Facebook and YouTube channels. It will be the same links. So yeah, just bookmark it and come back to it whenever you're free. And our speaker presentation slides will also be on our website in a couple of days' time. And you can stay connected with us by signing up to our mailing list on our website or follow us on our social channels. Do subscribe to our YouTube because we regularly host events with developers and startup communities. And in 2 weeks' time, we actually have a startup coffee chat that's based around health tech in Southeast Asia. So if you are working in the health tech industry, do join us for that event. And last but not least, we would love to hear your feedback about today's event. Let us know what you thought. Was the session too short? Was it too long? What would you like to hear more of in our future Lakopi? So feel free to scan the code or type in the link as well. And meanwhile, stay tuned to our upcoming events on our website and social channels. And we look forward to seeing you again.